So looking at question B, it's asking for domain and range. Domain means possible x values. And so if I'm asking what are the possible x values for these sets of ordered pairs, what I'm looking at is these values are underlined in red. Because it's discrete data, because it's points, it's just ordered pairs, nice and easy. All I need to do is go D colon curly bracket. That says domain is. And then I start listing my x values from lowest to highest. My lowest x value was -8. Then it was -3. Then it was 0, 2, 3. Those are the possible x values for this question. Range is asking for possible y values. All right, for possible y values, I go R colon curly bracket, and then I start listing my y values from lowest to highest. I don't need to repeat. So when I look at my y values, I have 4 3s. I only have to put it once. Because what I'm saying is 3 is a possible y value. I'm not saying how many times it happens, I'm just saying it's possible. The other one that's possible is 9. That would be your domain and range. For discrete data, for points, for ordered pairs, it's not that bad. It's pretty straightforward. Awesome. We're going to try a couple more. We'll look at A first. So graph A. We want to write the domain and range for this graph. If you look at this, it's discrete data. It's discrete data because it's not connected, right? There's only points here. And I can count those points. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 points there. Some of them I just make the lines, so I go straight up. Each one of those points has an x value and it has a y value. Right? If we look at this first point, it has an x value of -4, 4 to the left, and a y value of 0. Never went up or down. The next point would have a x value of -3, y value of +1, and so on and so forth. Because this is discrete data, and because I could just look at the points and know all the points, I can still just list my domain and range. So for domain, I go domain is, and then a curly bracket. If I look at this graph, and I ask myself, which one of these points would have the lowest x value, it would be the point that's furthest left. This one has the lowest x value. It's at -4. Then I'm going to list the next highest or next lowest, depending on how you want to look at it, the next lowest x value. The point with the next lowest x value would be right here. It has an x value of -3. And all I'm doing is listing the x values from lowest to highest. And you can just keep going with this trend, right? The next point is right here. It's at -2. The next point has an x value of -1. The next one has an x value of 0. 1, 2, 3, and 4. I've now listed all the possible x values for that question. I can do the same trick for y values. All right, so if I want to list y values, or the range, and I want to go from lowest to highest, the point with the smallest y value would be the lowest point. These two are the lowest points. They're both at the same level, same height. They both have y values of 0. So that's the point I'm going to start with. I'll go range is 0. And that's the lowest y value I can have. The next lowest y value I could have would be these 2 points. They have y values of 1. I'm at 0 here, now I'm at 1. I go up to the next lowest y value I could have. The next lowest y value I could have would be 2. Then 3. Then 4. 3, 4. And now I've listed all my possible y values for this question. It's a little tricky to do graphs that are discrete. We don't do it very often, but it is possible. Graph B is when things start to get a little interesting for us. So if you look at graph B, the problem we have is we couldn't possibly list all of our x values that are possible. The reason why is that this data is continuous, right? It's been connected with a line. That means in between every little point, there's an x value that counts. So I would have to, if I tried to list this all up, I would have to start with -4, or negative 4, it's right here. And then I would have to go back the smallest little decimal. I'd have to go back to -3.9. And then I have to put -3.8. And then you could think there's even smaller decimals than that, right? I have to go -3.9999. -3.99998. Right? And it would be ridiculous. Because that's what continuous data is. It includes every little decimal point from here to here. So when you have continuous data, this method of listing does not work. Instead, we use something called set builder notation. Is there a spot for me to just write some set builder notation? Just give me a second. Let's write about this graph. I'll put it right down here. I'm going to show you like the general format that set builder notation follows, and then we're going to try filling it in. Okay? So the general format is D, colon, curly bracket. Starts the same way. Domain is. Then you put an X and a big line, a bar. Right? That's what they call it. That bar means such that. So domain is X values such that, and then you have 2 blanks. You have blank, symbol, X, symbol, and then blank. Give me a second, because that's one symbol. Shouldn't have made this so big. That part. What we're doing is we're telling people the boundaries that the x values have to stay in between. The first number is the lowest boundary. Okay? Different ways of looking at that, but I'm just going to say the lowest x value. It's also the furthest left on a graph, because we usually do this stuff for graphs. And the lowest. How do I want to do this? The first blank, you put the lowest x value. Lowest possible x value. The second blank is the highest possible x value. Highest possible x value. The reason this is just a general format is sometimes you don't have a lowest value and sometimes you don't have a highest value. And I'll show you examples of that. All right, but for examples that do have a highest and lowest, this is exactly what it would follow. Right? If we were reading this. it would say domain is x values such that the lowest possible x value is less than all other x values, which is less than the highest possible x value. You're saying x could be anything in between these two numbers, whatever your lowest and your highest is. That's what this part is saying. X could be anything in between the lowest and highest x values. Every little decimal in between. We do have to tag one more thing on the end. So you go comma, and you say x is an element of the reals. That's telling you that it can be any real number in between those two numbers that I said. Sometimes it can't be any real number. Sometimes it can only be whole numbers in between two numbers. Sometimes it can only be integers in between two numbers. Sometimes it can only be rational numbers in between two numbers. But 99% of the time, it's x is an element of the reals, meaning it can be any possible number in between two values. All right, let's look at how this actually works for a question. So we've got this graph right here. How do I get rid of that little circle? That's wonderful. I've wanted to get rid of that all year. So look at this second question here. Graph B. We have to use that format, set builder notation, to state the domain. It starts off with D, colon, curly bracket, x, such that, x bar. Domain is x value such that. Then you look at your graph and you ask yourself, is there a lowest x value on that graph? Is there a moment where this graph doesn't go any further left? It cuts off somewhere. There it is, right here. That graph stops going left. That's the smallest x value I could possibly have. That goes in the first line. I say -4 is the smallest x value. Then I do my little symbol. And then I put x. Reading this means that -4 is less than or equal to all the other x values that I'm allowed to have. Then I ask myself, is there a highest x value that you could have on this graph? If you look, is there a moment where the graph doesn't go right anymore and it stops? If you follow your line, it stops going right there. It's the furthest right it ever goes. That moment is at positive. And then I tack on XER. That was really messy. I'm going to erase that. Sometimes it likes me, some days it doesn't. X. I mean, it is kind of a weird E. It's not like a normal E. It's like a lowercase capital E. It looks weird. It's like a really small capital E, but it's kind of curved. It's because it's actually not an E, but we just call it. What this domain says is that for this graph, the domain is x value such that -4 is less than all the other x values, which is less than +4. X can be anything else as long as it's in between those two, which is true, right? If I look at this graph and I chose an x value in between 4 and -4, I would be somewhere on this graph. If I said x equals 1, x equals 1 is right here. Yep, the graph has a spot at x equals 1. If I said, well, what if x equaled -2.5? I go to -2.5. Yep, there would be an x value on the graph right there. This is just telling you possible x values for that graph using set builder notation. Range is the exact same. However, it's y values. So it would be the exact same format you have here. Just change the d to r and the x's to y. It's the exact same format. So if we're looking at this question, we're going to go range is y such that the first blank is the lowest possible y value you could have. On a graph, that means the lowest point, the furthest down you could go. On this graph, the lowest I could ever go, the smallest y value is at these two spots. They both have a y value of 0. Right? That's the lowest the graph goes. It never goes below that marker. Then I do the same symbols. I change my x to be y. And my second blank is the highest possible y value I could have. The highest this graph ever goes is right here. Right? It doesn't go above that marker. That marker is at positive 4. Then I say comma, y is an element of the reals. That's how you would use domain and range for a graph, for a continuous graph. Awesome. Now that was a continuous graph that did have like a furthest left, furthest right, a highest and a lowest. Sometimes you don't have that. So if you look at question C, you actually don't have some of those restrictions. So we need to see how you would do your domain and range if you were stuck with things that didn't have perfect restrictions. Let's look at domain first. So looking at question C, domain is curly bracket x such that. And that's always my starting point. My first blank is my lowest possible x value. If you look at this graph, lowest possible x value means the furthest left this graph can go. This graph goes left, 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 and then there's an arrow. That arrow means that it goes forever in that direction. It's going to keep going forever and ever and ever and ever and ever. So is there a lowest possible x value? There's not, right? If there's not a lowest possible x value, you don't have to write the first blank, and you don't have to write the first arrow. You get to just ignore that part of it. And you would move on to the next spot, which would be x, and then arrow, and then highest possible value. If you look at this graph, highest possible x value means the furthest right it ever goes. It's going, it's going, it's going, and then there's an arrow. That arrow means it goes forever in that direction and never stops. Is there going to be a furthest right moment? There's not. It's going to keep going forever to the right. When you have something that goes forever to the right, you get to ignore the second arrow and the second blank. In this question, because there was no lowest and there was no highest, you actually get to just ignore this entire section of the set builder notation. Because there is no boundaries. It goes forever in both ways. We represent that by saying x is an element of the reals. And then you close the brackets. So you get to ignore all the stuff in the middle because there was no lowest, there was no highest. That happens a lot. The range is a bit more of an interesting one. Because the range does have a restriction, but only one of them. So, range always starts off as R is Y such that. That's how it always starts. Then you put your lowest possible Y value. Lowest means the lowest a graph will ever go. Right? How far down does it go? If you look at this graph, it's going down, 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 and then it hits an arrow. That arrow goes forever, and it goes forever downwards. So there is no bottom to this graph. It'll go down forever. Because of that, we ignore the first blank, we ignore the first arrow. Then we move on to the next arrow and the next blank. If you look at this graph, there is a highest moment. Right? There's a moment where that graph peaks. It doesn't go above a certain spot. Right here. It never goes above that. That is at y equals 4. So I do need to put y and then less than or equal to and then positive 4. That is telling me that y is less than 4. It's below 4. And then you do tack on there, comma, y-e-r, which tells you it can be any real number less than 4. This graph is anything below 4. It goes forever down after 4. That's domain and range. You don't have any questions about the blanks, where things come from, why we use curly brackets instead of normal brackets. I don't know the answer to that, so I'm asked that. Awesome. There's a question here. There's 4 of them. A, B, C, D. I want you to try A. We're going to do these one at a time. So try A on your own. And we'll talk about it. And we'll do our manage together. Alright. There we go. Let's look at this first one. So we've got this graph, it's got like that curve to it, it's going upwards. We're going to do domain or range. Because it's continuous data, I have to use that weird thing called set builder notation. Right? That's the one that has like those rules in the general format. We'll start with domain, because I find that easier. Domain is X such that. That's how it always starts. Domain is X value such that, and then you put in your rules. Okay, the first rule you put in is the furthest left this graph can go. The lowest possible X value. You look at this graph and you follow the line, it goes left forever until it hits that arrow, which keeps going. That means there is no left bound. This thing goes forever to the left. So I skip the first blank, I skip the first arrow, I move on to the next blank and the next arrow, which tells me how far right I can go. I follow my graph, it goes to the right, and then it goes forever to the right. And it's going up and to the right forever. That means there is no highest value. So that middle chunk of your set builder notation is irrelevant because there is no lowest, there is no highest. All you need to say is that X is an element of the reals. That means it can be any possible X value, forever left, forever right. Range. We want to do the range for this thing. We understand that we're using set builder notation, which always starts like this. Range is y such that. The first blank is the lowest y value you can have. The lowest y value for a graph is how far down it goes. If you follow this graph, the lowest point it ever goes to is right here. The y value at that moment is -1, -2, -3. That's the lowest the graph ever goes. Now, I've taught this course a lot of times, and we do a lot of domain range in grade 11 and a lot in grade 12 as well. Over and over and over again, people say that the lowest value is -2. Like they look at this and they notice that y-intercept and they think that's the lowest the graph ever goes. Remember, you're thinking, how low does it go? Not where's the y-intercept, right? It goes down to that moment. That's the y value you have to use. Okay, so don't fall for that trick of getting those two concepts mixed up. Then you need to do an arrow and your highest that the graph ever goes. If you follow this graph, it goes up forever. Actually, it goes up forever in two different directions. Because it goes up forever, there is no restriction on the highest point. So you have to ignore the second arrow, ignore the second blank. And you just tag in there, y is an element of the reals. That is your domain range for the first graph.
If you had one end had an arrow but one end didn't, would there be a different way to do the question?
That's a good question. For domain, it would change things. Because then there would say the left one wasn't an arrow, so let's just pretend it's a dot. Right? So instead of an arrow, they put a big dot here. Now I would have a lowest left side, but I wouldn't have a lowest right. So it definitely changed my domain. My range wouldn't change, because even though it tops out here, it goes higher later on. So your range would stay the exact same. That's a good question. Awesome. Try B on your own. So you got another graph here. You're going to do set builder notation because it's continuous, right? It's a line. So see if you can figure it out. If you've got that one and you're like, yeah, I'm good, see if you can do C or D. Actually, do D first. Go A, B, D, C. Okay, but we'll give everyone a chance to do B right now. Let's look at B together. So we'll start with domain. I go domain is curly bracket X bar. X slash that. And that's what that bar means. Looking at this graph, the first blank is the lowest possible X value. That's the furthest left it goes. Looking at this graph, the furthest left it goes is right there. Right? It never goes further left than that point. Right there. See, and that's a tricky one too, because people look at the x-axis, right? They get it drawn up here, and they go negative 1.5. It just draws your attention, right? But realistically, that circle kept coming out a little bit further. So that means there are possible x values even further out. The negative 2 would be the lowest possible x value you could have. Right? That left boundary, it gets all the way out to negative 2. The highest x value is the furthest right a graph goes. So now that we know that we're not following the x-axis and we're looking for the furthest right it goes, hopefully we notice that this is the furthest right it ever goes. That point is all the way out at 4. So for this graph, x could be anywhere in between negative 2 and positive. And then you throw in the x as an element of the reals. This could be any real number in between those two. Right? Every single decimal point. Range. Range, we're going to do the same kind of thing. Y such that. The lowest possible y value you can get. The lowest this circle ever goes is about right here. That's at negative 1, negative 2, negative 3 is the lowest this graph ever goes. So negative 3 is less than y, which is less than the highest point, which is up there. That's at positive 1. And y, e, domain and range are giving you boundaries where your values have to be between. For this left, for this right, lowest, highest. Awesome. We're going to look at C. We do so many graphs, and we do so much set builder notation, that sometimes we get to a question like C on a test, and we forget how to do the basics. Okay, this is a very basic question. It is just points. Right? You just have to remember which one's your x and which one's your y. X has the arrow coming out of it. These are my x's. Y has the arrow coming into it. These are my y's. When you have discrete data like this, all you have to do is list it. So for this question, domain is curly bracket 1, 2, 3. That easy. Right? When it's discrete data and it's limited, and you can see all the x values, just list them. Makes your life easier. Range, same thing. Range is curly bracket 2, 6. Fantastic. For D, D is a little more of an advanced question. I think it's best to sketch D. You technically don't have to, right? But I'm going to. So it says a circle with center -2, 3 and a radius of 3. They've given me a point. I'm going to put that point on a little sketchbook graph. Try to do this nicely. Okay, we're going to use, I need to color here. It's not very good, but it'll work. Okay, there's my little Cartesian plane, my x's and my y's. They said there's a point at -2, 3. -2, 3 is right here. Okay, that's the point that they gave me, -2, 3. Then it says a radius of 3. Radius is the distance from the center of circle to the outside edge of the circle. Right? That's what radius means. So if you look at this, I could then figure out a few more points. I could go left 3, 1, 2, 3, and that would be a point. Right 3, 1, 2, 3, that would be a point. Up 3, 1, 2, 3, down 3, 1, 2, 3, and make a circle. That's what they just described. A little trippy, right? A little hard to get. I think the picture helps, but drawing the picture is not easy. So I started at my center point, -2, 3. I knew I had a radius of 3, so I figured out how far left, how far right, how low, and how high I could go, and then I just made a circle with those points as my boundaries. Now I can do domain and range on that. The same way that I do domain and range on the circle above. So if I'm looking at my domain first, domain is x such that the lowest this goes is -2, 3, 4, 5, -5 right here. So the furthest left my graph goes. That's less than or equal to x, which is less than or equal to the highest it ever goes. The highest it ever goes is right there at 1. Then you throw in XER. So x can be anything in between those 2 points. The graph is somewhere in between. Range, lowest, highest. Switch colors. Follows the same format. Range is y such that the lowest y value I have is right there. It's at 0. Less than or equal to y. Less than or equal to the highest point it ever goes. It's up there at 6. Then you say y is the element of the zeros. That's domain and range. We'll do a couple extra questions that maybe just extend our thinking. But if you've got that down and you feel like you could consistently do that, then you're doing good with domain and range. Okay? And then it's just kind of applying it to different situations. So the class example 4, they're going to ask us to draw a graph after they give us a domain and range, which is a little bit tricky. All right, looking at number A, it says draw the graph of a relation that has a domain of XER and a range of y is less than or equal to 2. It then gives me another restriction. It says you can only have one X-intercept. So, here's my beautiful graph. My XYs, these are my X's, these are my Y's, X, Y. I need to build a graph that goes forever to the left and forever to the right. That's what XCR means. That that graph also must follow my range rule. My range rule is that y must be less than or equal to 2. I'm going to make a little marker at 2. Let's pretend that's 2. Yep. So my graph has to go forever to the left, forever to the right, and be below that point. That's what the domain and range told me. Then it also has to only have one x-intercept. So if I were to draw this, and you could draw like a ton of different ones. There's no singular answer. Okay. As long as it follows the rules I'm about to follow. It has to go forever to the left. I'm just going to put one that goes forever to the left, going downwards. And I'm going to start drawing a line upwards until I hit my boundary. And then I'm going to just go beside my boundary like that. I'm going to say it's at 2 now, and it goes forever to the right. This graph goes forever left, forever right. It's below 2, and it only has one x-intercept. You could have drawn a way different picture and still got the right answer, as long as it follows the rule I just said. Forever left, forever right, one x-intercept, doesn't go above 2, goes down forever. Kind of tricky, right? I mean, like, it gets a little harder. We try number 2, we're going to draw 2 x-intercepts. So it's the same rule, but now you're wanting 2 x-intercepts. Try it. See if you can draw it. It has to follow the rules: forever left, forever right, forever down. Can't go above 2. Has to have 2 x-intercepts.